We are in the new topic of the calculus. It's going to be the third part. The first one is the limit and continuity. The second one is about the derivative. And now we're going to go to the thing that called antiderivative of the function. And the thing that we're going to study is called integration. So this one is going to be kind of an opposite of the derivative. So we call this thing antiderivative. So you're going to have the prefix anti in order to indicate that it's going to be the procedure that like opposite of the derivative that we have been studying. So in this lecture, we're going to talk about the antiderivative and the rule of integration. We're going to talk about the antiderivative, basic rule of integration, and we're going to know that it's going to be kind of the inverse of each other. So we're going to have integrate of f prime x going to turn out to be able to recover the function f. So first of all, let's consider the first example. You have fx equal to x cubed plus pi, x cubed minus 5, and x cubed plus c. The question asks you first to find derivative of this function. And you may feel that, hey, why do we need to find derivative of such an easy function? So you get f prime x equal to 3x squared. And another thing will be f prime x equal to 3x squared as well. And you have f prime x to be 3x squared. And finally, you have f prime x also equal to 3x squared. So you see that the thing that will matter turned out to be the function x cubed. The constant multiple that you have plus pi minus 5 and plus c doesn't matter at all. So you have the same derivative. Similarly, for the second one, you have fx equal to sine x plus 4, sine x minus square root 3, and sine x plus c. So you see that this guy, you have sine x, sine x, sine x, sine x, that will matter. And you see that the constant, you're going to differentiate constant, you're going to get 0. So for the second one, you have f prime x equal to just differentiate sine, so you get cosine x. Okay, so you see that the function that we have here are different with constant. So it's going to be addition with constant. So you have sine x plus 4, sine x minus root 3, sine x plus c. They are having the same derivative, cosine x. Okay, so they are the function that have derivative cosine x. We see that if you like to differentiate this guy, so you have x cubed or sine x, the thing that matter is going to turn out to be just the yellow guy and the pink guy. The plus c constant turn out to be doesn't matter at all. Okay, so you have this one. So we're going to call the function capital F an antiderivative of the function small f. Okay, so we have the capital F is an antiderivative of the small f if you have f prime equal to the capital F prime equal to fx. Okay, so what is going to be? So let me explain this one in this way. So you have the function f, okay, and you have the function f prime before. So you see that you have function f, and the thing that we have been studying is going to be f prime, and this guy is called derivative. Okay, so this one is called derivative, and the action that you are finding the derivative is called differentiate. Okay, so when you differentiate, this guy will give you the action. So it's going to be verb, And for derivative, it's going to be now. Okay, so in this one, if you go forward, you get derivative of the function. However, the question turned out to be we like to recover the function that has derivative equal to f here. Okay, so we like to recover the function that will have derivative equal to the given function f. So this one will be you gonna find the function. So you're gonna find the function capital F, okay, that will have derivative equal to the small f. Okay, so this guy f prime equal to the small f. Okay, so this one will be called antiderivative. So the function capital F will be antiderivative. Okay, so this one will be antiderivative, and you see that we have a prefix anti. Okay, so for the rest of the course, we're gonna spend time studying this guy. Okay, so it's gonna be about half of the course that we're gonna study how to recover the function. And the procedure that we're gonna do is gonna be kind of backward procedure. So this one, we like to find this guy. And in order to find the capital F, we're gonna integrate. So this one is gonna be your verb, okay? And you see that we're gonna have the procedure. So if you have your F in the middle, okay, so you are having your F in the middle. So you're gonna go forward. So if you go forward, it's gonna be you get derivative. If you go backward, you're gonna get the antiderivative. Okay, so this will be the key thing that we're gonna study for the rest of the semester. So this thing is called antiderivative. Okay, so for this one, you see that for this function, you see that this guy will be your f, and this guy will be your capital F, and this guy will be your f, and this guy will be your capital F. So you're gonna say that your capital F and your F here, and this one is your F and your capital F. So you're gonna say that x cubed minus 5 is an antiderivative of 3x squared, and sine x plus 4 is an antiderivative of cosine x. Okay, so that is going to be read. And when you read it forward will be 3x squared is a derivative of x cubed minus 5. Cos x is a derivative of sine x plus 4. Okay, so that we read it in the forward way. If we read it in the backward way, it's going to be 3x squared, not 3x squared, x cubed minus 5 is an antiderivative of 3x squared, and sine x plus 4 is an antiderivative of cosine x. And you see that you may read this guy as x cubed plus c is an antiderivative of 3x squared, and you have sine x plus c is an antiderivative of cosine x. Okay, so this is how we get the antiderivative. So you see that if you have the capital F is an antiderivative, you may add by any constant. So if you add by c, it also give you all antiderivative. So all antiderivative of the function f turn out to be f the capital F plus c, where c is an arbitrary constant. The next example asks you to find the antiderivative of the following function. You have fx equal to 2x, okay? So the thing that you may have to think of will be you have 2x, and you would want to recover the function that has derivative equal to 2x. And we did this one many times. Okay, so you like to have the function that has derivative equal to 2x. And the thing is, you like to have derivative of this guy equal to 2x. Okay, so this is the idea that you may have to keep in mind. Okay, so you like to dip something equal to 2x, and you will answer that it's going to be just x squared. Okay, so you'll be able to know that it's going to be dip x squared equal to 2x. So you're going to just have x squared. However, it's not going to be only the x squared that derivative equal to 2x. So you may just write down x squared plus 1, x squared plus arbitrary constant c. Okay, so this one will be x squared plus c equal to 2x. So you're going to answer x squared plus c is an antiderivative of 2x. Okay, I need some space on this one. So you have x squared plus c is an antiderivative of 2x. Okay, so this is how we answer. The next one, you're gonna have secant square. The equation, you have secant square x, and you would want to recover, okay, the function that will be derivative equal to secant square. Okay, so in this case, you're gonna know that you like to div this guy, the dx of this function turned out to be secant square, and the thing that you will get will be just the function tan x, and you may plus constant c. Okay, so you're gonna answer tan x plus c is an antiderivative of secant square x. Okay. Okay, so this one will be just easy. And the next one, okay, you like to find the function that has derivative equal to 6. So you need the dx of what? Equal to 6. And you're gonna answer 6x. Okay, so you dip 6x, you're gonna get 6. So you get 6x plus c is an antiderivative of 6. Okay, and finally you're gonna differentiate what equal to 1 over 1 plus x squared. Okay, and for this one we learned that when you like to find derivative of arctan x, you will get this number. Okay, so you get dip arctan x equal to 1 over 1 plus x squared. So you're gonna say that arctan x is an antiderivative of 1 over 1 plus x squared. That's all. Okay. The next one will be the notation that we shall use for this course. Okay. So we're gonna talk about the thing that called indefinite integral. For the indefinite integral, it's gonna be the notation that we will use for the antiderivative of f. So we learned before that the antiderivative of f is the capital F, okay? The capital F. We're gonna use the integral sign. So the integral sign look like this. Okay, so we're gonna use the integral sign in order to indicate the like a backward procedure that we find the antiderivative of the given function f. So for this one, okay, we use the integral sign. Okay, so the integral sign. Okay, and you're gonna have the function inside here. This thing is called integrand. Okay, and your dx here is the variable of integration. It will tell you the variable that you are integrating with respect to. Variable of integration. Okay. And the action that we are doing is going to be, this thing is called integrate. So in order to obtain this one, the action is integrate. Okay, so this one is your verb, and you're gonna read the whole thing. Okay, so you're gonna read the whole thing. Indefinite integral. I don't have to say anything because I already write this one down. Let me just how could I underline this one. So this one is going to be read indefinite integral of fx with respect to x. Okay, indefinite integral of fx with respect to x. Okay, so normally this one we're gonna say in short that integral of fx dx. Okay, so you're gonna say this one in the way that you're gonna have the integral of fx dx. Okay, so this one will be the kind of a nickname for the indefinite integral of fx with respect to x. Okay, so in symbol, you see that this one will be the function inside my box before. Okay, so you dip the function inside my box, it's gonna turn out to be the function small fx. Okay, so you have derivative forward. So this one, if you go in this direction, you get derivative. Okay, so for this one, you see that your function in the box is on the other side like this. So this one is going to be antiderivative. Okay. Okay. So let me use the notation that we just discovered here in order to write the previous one shorter. So you see here that you're gonna say that, okay, so this one, let me box this one a little bit. Okay, so when you dip x squared plus c, you get 2x. So in terms of integral, you may just write integrate 2x dx equal to x squared plus 4. So you see that your box is on the other side. Okay, so like we have before, so the capital F is on the right side. The next one, in order to write tan x plus c is an antiderivative of secant square, it's going to be kind of too long. So we're going to just integrate. Okay, so it's going to be integrate secant square x equal to tan x plus c. Okay, and you're going to integrate 6 dx equal to 6x plus c. And you're gonna integrate 1 over 1 plus x squared dx equal to r tan x plus c. Okay, and the function inside the box is here. Okay. Okay. So we're gonna develop the formula or the rule of integration. So the basic rule of integration will be, so we learned before that when you differentiate kx, okay, so if you differentiate kx, it's going to be just k, okay, so you differentiate kx, it's going to be just k. So in this case, you see that this one is inside the box kx, so you're going to have your box on the other side. So in the way of integral, it means that you're gonna integrate k dx. It's gonna turn out to be kx plus c. Okay, so you integrate k dx is gonna be kx plus c. For example, if you integrate 3 dx, it's gonna be 3x plus c. Okay, and integrate root 2 dt is going to be root 2. However, this one is not going to be x because the variable turned out to be t. Okay, so the variable turned out to be t. So you're going to use the corresponding variable. So it's going to be root 2 t plus c. And finally, you get negative pi and dx, so it's going to be negative pi x plus c. Okay, so this is how we integrate constant. Okay, that's called constant rule. The next one will be constant multiple. So constant multiple give you or present you in the way that if you have the constant, you'll be able to just move this constant outside the integral. So you may just ignore the constant and then you just integrate only the function. Okay. And you have the sum and the difference rule. So if you like to integrate fx plus gx dx or fx minus gx dx, so the sum and the difference turn out to be, you'll be able to integrate fx and then you integrate gx and then you just sum them. So it's going to be like a term by term. Okay, so we're going to say that this guy is going to be integrate term by term. Okay, so we integrate term by term and we just add or we just subtract the function. The next one, we know that you differentiate x to the n plus 1. Okay, I'm going to box this guy. So I differentiate n plus 1, you get n plus 1 to the x to the n. Okay, so we do this one first, and I'm gonna divide the whole thing by 1 over n. Sorry. So I'm gonna divide the whole thing by 1 over n plus 1. Okay, so you're gonna get derivative of x to the n plus 1 over n plus 1 equal to x to the n. So in this case, I'm gonna box x to the n plus 1 over n plus 1. Okay, and this guy turned out to be the derivative equal to x to the n. So you're gonna say that integrate of x to the n. Okay, so it's gonna be, you're gonna integrate of x to the n equal to x to the n plus 1 over n plus 1 and u plus c. So this one is called the power rule. Okay, it can be used. Okay, it can be used when n not equal to negative 1. Okay, so the antiderivative of x to the n turn out to be x to the n plus 1 over n plus 1 plus c. Okay. For example, you have integrate of 6x squared dx. So your 6 here is your constant. Okay, so your 6 here is your constant. So this guy can be done in the way that you have 6 outside and you just integrate x squared dx. And you see that you have 6, okay? And you just integrate x squared. So here you have n equal to 2. So you're gonna get x to the 2 plus 1 over 2 plus 1 plus c. Okay, so you see that we're gonna just integrate this guy and you're gonna just plus c. And you see that we be able to get rid of this guy. So you would get 2x squared, not 2x squared, 2x cubed plus c. Okay. The next one, you have 1 over root x. So this guy, if you write in terms of power function, so it's going to be 1/2 negative dx. And it's going to turn out to be x to the negative 1/2 plus 1 over negative 1/2 plus 1. Okay. And you're going to plus c. And it's turned out to be x to the 1/2 over 1/2 plus c. Okay, so this one will be kind of important. Let me write this one down a little bit. Okay, so for this one, you integrate 1 over root x is gonna turn out to be just 2 root x. Okay, so this guy will be equal to 2 root x plus c. And this one will be the one that normally you have on your quiz, your exercises, your exam. Okay, integrate 1 over root x dx is going to be 2 root x kind of automatically after this. Okay, so that will be kind of the thing that we normally use. Now the next one, okay, we're gonna find the derivative of exponential function. So we have shown that when you dip e to the x, okay, so when you dip e to the x, it's going to be just e to the x itself. Okay, so when you integrate, you're going to get e to the x plus c to be your integral of e to the x dx. And you dip a to the x, okay, so you get a to the x log a. So in order to obtain the antiderivative, you see that log a will be constant and you just divide by 1 over log a. So you get the dx of a to the x over log a equal to a to the x. Okay, so this one will be your antiderivative. Okay, so it's going to be integrate, not, so it's going to be integrate a to the x dx will be a to the x over log a. Okay, and the last one, you have dip log x. Okay, so you dip log x, it's going to be 1 over x dx. So you're going to have integrate 1 over x dx equal to log absolute x plus c. I have shown you also, right? When you have absolute, okay? So dip log absolute x is turned out to be 1 over x. We have done this before. So when you integrate 1 over x dx, it's going to be x to the negative 1 dx. So it's going to be log x plus c. Okay, so this is how we integrate this. And we're going to apply this formula, integrate e to the x. So it's going to be e to the x plus c, and indicate a to the x is going to be a to the x log a plus c. So it's going to be a to the x over log a, sorry. Okay, so in this case, you like to integrate 2 to the x. So this one, let me emphasize on something. The thing that you make mistake is going to be you forgot log a on the bottom. Okay, so integrate a to the x is not a to the x, it's going to be a to the x over log a. So in this case, you have a equal to 2. Okay, so you have a equal to 2. So this guy will be 2 to the x over log 2 plus c. Okay, so this one will be your 2. And integrate 3 to the negative 2x. So it's going to be integrate. I'm going to have to write this one. So it's going to be 1 over 3 to the 2x dx. So it's going to be equal to 9 to the x dx. Okay. So this guy will be 9 to the x over log 9 plus c. Okay, and in this case, a equal to 9. Okay. Okay, so this is how we have this formula. And the last one is integrate 1 over x dx turn out to be log x plus c. So this one will come from the dip log absolute x equal to 1 over x. The next one will be about integration of trigonometric function. So we learn dip psi equal to cos, dip cos equal to negative psi. We be able to read the formula backward. So if you dip psi equal to cos, you integrate cos, you will get psi. Okay, dip psi equal to cos. So we have the dx of psi x equal to cos x. Okay, so when you read this guy backward, it's going to be integrate cos equal to psi, and you dip cos. Okay, so you're going to dip negative cos, so it's going to be negative of negative psi. Okay, and this guy will be just psi x. Okay, so you dip negative cos equal to psi, so you integrate psi equal to negative cosine. Okay, and we have learned before dip tan is sec square, so integrate sec square is tan. Okay, so that one like a backward forward formula, and dip sec is sec tan. Okay, so you integrate sec tan, you will get sec. Okay, and we learn about dip arc psi. Okay, so we dip arc psi x, so it's going to be 1 over square root 1 minus x square. So this one will be just integrate 1 over square root 1 minus x squared is going to be arcsine x. Similarly, you differentiate arctan x, so it's going to be 1 over 1 plus x squared, and you're gonna get derivative of not derivative, integrate of 1 over square root 1 plus x squared dx is gonna turn out to be arctan. Okay, so this is how we have. So let's try to do this example. Okay, so let's try to do this example. Okay, so you like to integrate x plus sine x minus 5 to the x. So for this one, you see that we be able to term by term. Okay, so you just integrate x squared, it's gonna be 2x. Integrate sine equal to negative cos. Okay, and integrate 5 to the x is gonna turn out to be 5 to the x over log 5. And then you add by arbitrary constant. Okay, so this is how we get this one. Let me write this guy in the way that negative cos x. Okay, and I'm gonna separate this one for you. So indicate x squared, you get 2x. Indicate sine, you get negative cos. And you integrate 5 to the x, you get 5 to the x over 5. Okay, so this one will be term by term. For another one, you want to integrate to x cubed. Okay, so this one you see it's going to be constant 2 times x to the 3 plus 1 over 3 plus 1. And you have constant 4. Integrate this guy is going to be arc sine x. Okay, and plus c. So this one will be your first term and your second term. Okay, so this one, if you like write this one in a simple form, so you're gonna see that you'll be able to get rid of 2, so it's going to be 2 and 2, so it's going to be x to the 4th over 2 plus 4 arc sine x. Plus c. Okay. The next one, you see that it's going to be quotient, and we not have the quotient rule for integration yet, so we're gonna simplify this one. Okay, so for this one you may simplify this one as you can just have integrate e to the x over x minus 3 over x dx. So it's going to be integrate e to the x minus 3 over x dx. And you see that this guy will be just e to the x minus, and 3 is the constant, and you just integrate 1 over x. Integrate 1 over x is going to be log absolute x plus c. Okay, so this is how we have this integral. This guy will be e to the x, and the second term take care 3 over x. Okay. The next one seems complicated. So you have integrate of x minus 3 root x plus 2 over 1 minus root x. So this one you see that it looks like quadratic. So you're gonna just try to write this one as square root x squared minus 3 root x plus 2 over 1 minus root x dx. And you see that you'll be able to factor this term, okay? So you'll be able to factor this one as 2 parentheses dx, and it's going to be root x minus 2 root x minus 1, and you're gonna divide by 1 minus root x, okay? And you'll be able to cancel these two guys, so you get negative 1, and this guy will be integrate root x minus 2, and you'll be able to pull negative 1 outside. Okay, and so you just integrate root x and integrate 2. What is root x? Root x turned out to be just x to the 1/2. So this guy is x to the 1/2. So you get negative, and x to the 1/2 is x to the 3/2 over 3/2 minus 2x. Okay, and you plus c. Okay, so this is how we obtain your final answer. Okay, so this one I should use the green color, right? So this guy is your negative side. Okay, so you may write your answer in this way, or you may flip 3/2 up, so you get 2/3. Okay, quite doesn't matter for me. The next one, you like to integrate 1 minus x squared over 1 plus x squared dx. So for this one, you do the same thing. You're gonna just write this one as 1 over 1 plus x squared minus x squared over 1 plus x squared dx to see what's going on first. And you see that you have no problem with this term. This term turned out to be just arctan x. Okay, so this term is going to be just arctan x, no problem. However, okay, however, you see that this guy is seem different because we not have any formula for integrate this guy and integrate this guy, and it's not going to be integrate the top divide by integrate the bottom. So in this case, we're going to do some trick like you're going to add by 1, subtract by 1. Okay, so this trick will be you're going to add by 1, subtract by 1. To see what's going on, let me write this one down. So it's going to be negative, right? And let me so you need to integrate, and you see that you'll be able to again separate this one into 2 terms. So you're gonna get x squared plus 1 over 1 plus x squared, okay, minus 1 over 1 plus x squared dx, okay. I don't have the x yet. Oh, okay, and then you see that this guy turned out to be arctan x minus, and you see that this guy you integrate x squared plus 1 over 1 plus x squared, which is turned out to be 1, and you have 1 over 1 plus x squared dx. and you see that this guy turned out to be arc10x minus, okay, and you integrate 1, you get x. You integrate 1 plus x squared, so you're gonna get minus arc10x plus c, okay? And so you may combine everything together. So you get what? You get one arc10 and another arc10. So it's going to be 2 arc10x. And you have minus x plus c. Okay, so this is how we obtain your final solution. So you see the thing that I integrating, I have 1 integrate 2x. I have this term integrate to be 1, to be arc10x. For the next one, you have integrate 10x minus secant x squared dx. So for this one, you see that we again have no product rule for integration. So we're gonna try to expand this one in order to obtain the sum or the difference between function that we be able to integrate it term by term. So for this one, you integrate, so you get 10x square. Okay, so the first term square minus 2ab, so it's going to be 2 10x sec x, and you have plus secant square x. Okay, and you see that you have no problem with this guy. Okay, so you be able to integrate 10 times x is going to be sec 10 and integrate, so this one turned out to be 2 sec x 10x. Okay, so this guy turned out to be 2 sec x 10x, and you be able to integrate secant square. Integrate secant square is 10, we have learned before. So we have the problem only this term. Okay, so how would we integrate 10 square? So for this one, after we expand, so we gonna don't know how to integrate 10 square, but we know the identity. So we may apply the identity. So we know 10 square can be written in terms of secant square. So this guy is secant square x minus 1. Okay, so for 10 square, it turned out to be secant square minus 1. And you see that we be able to integrate secant square. So that's what we gonna do. So here it's gonna turn out to be integrate. Okay, so 10 square turned out to be secant square minus 1. Okay, the second term turned out to be 2 sec x 10x, that we know the formula. The last term, you get secant square x dx. Okay, and now we be able to integrate every guy. So you integrate sec square, you get 10x. You integrate 1, you get x. You integrate sec 10 is going to be 2 sec x. And you integrate sec square, you get 10x. Okay, so you get 2 10x minus x minus 2 secant x plus c, okay, for your final answer. Okay, so you see that this one you may have to play with algebra. Okay, so you first expand, okay, here to here you just expand. However, here you need to use strict identity. Okay, so in order to obtain the final solution. We learned that if fx equal to integrate fx dx, we be able to have f prime x equal to fx. So it's going to be like we learned this thing before, that you have this guy in the box, okay, and you dip the box, you get the small f, okay. However, if we know f prime, okay, if we know f prime and we integrate f prime, we gonna just recover the function f. So it's like you have integral sign and differentiation sign cancel each other, okay. So for example, if you like to find the function f that satisfies f prime x equal to ax plus psi x, you're gonna just try to get rid of the prime side. The way to get rid of the prime side will be you're gonna integrate, okay? So this one, let me say some word on this kind of equation. This equation that we have here that you are asking to solve for x, okay? So this thing is called differential equation. Okay, and this guy asks you to solve for f. Okay, let's see. You have f prime x equal to 8x plus psi x. So you have f prime x. So if you like to find fx, it's gonna be integrate f prime x dx. So it's gonna be integrate ax plus psi x dx. Okay. So this guy will be, you integrate 8x, so it's going to be 8 times x squared over 2. And integrate psi, you get cos x, okay, plus c. Okay, so you get 8 plus c. So in this case, you're gonna have 4x squared plus cos x plus c. Okay, so that my fx. However, you see that we have arbitrary constant c that we don't know. Okay, so it's gonna be, you have fx equal to some function. Let me underline this guy. So it's gonna be some function plus c. Okay, so this one is your first step. Yeah, this one is your first step. For the second step, you're gonna find C, okay? So we're gonna find C by using, okay? You're gonna find C by using F pi over 2, okay? Equal to 2 pi. Okay, so we're going to use f pi over 2 equal to 2 pi in order to help us to find this c. Okay, so you're going to find this constant c by using f pi over 2 equal to 2 pi. So you get 2 pi equal to f of pi over 2. So it's going to be equal to, you just plug into x, so it's going to be pi over 2 square plus cosine pi over 2 plus c. Okay, so you get, I make mistake, right? So this one integrate sine, you get negative cos. Okay, sorry, negative cos, okay, and this guy is negative cos. Sorry about that. Okay, you may confuse here, and you get 2x, not 2x, 2 pi equal to, this guy turned out to be just pi square. Okay, and what is cos pi over 2? Cos pi over 2 equal to 0. So basically you get this guy plus c. Okay, and you would have c equal to 2 pi minus pi square. Okay, so the third step, you're gonna answer. Okay, so you're gonna answer this guy in the third step. Let's answer first. So you get fx equal to, let me copy the pink guy down, 4x squared minus cos x, and you're gonna add by 2 pi minus pi square. This one will be this term, okay? And you have plus 2 pi minus pi square, and this one will be your third step. Okay, so this one will be your final answer. So you have 1, 2, and 3. The second one, you have f prime x equal to 1 plus e to the x minus 1 over x, and f1 equal to e. Okay, so in this case, I forgot something. I forgot to give you the color here. Okay, so this one will be the thing that we have, and you have c equal to 2 pi minus pi square. The second one, you have f prime x equal to 1 plus e to the x minus 1 over x, and you have f1 equal to e. So you're gonna have fx equal to integrate f prime x dx. Okay, and this guy you will get integrate 1 plus e to the x minus 1 over x dx. Okay, so you get integrate 1 is going to be x, integrate e to the x is going to be e to the x, and integrate 1 over x is going to be log absolute x. Okay, and you're gonna plus c. Okay, okay, so this one you have fx. So the second step, you're gonna find c by using f1 equal to e. You're gonna find c by using f1 equal to e. So in this case, you get e equal to f of 1. So you just have 1 plus e to the first minus log e plus c. Okay, and log e equal to, not log e, log 1, log 1. And log 1 equal to 0. Okay, so log 1 equal to 0. So in this case, you're gonna have e and e on the other side cancel each other. So you get c equal to negative 1. And so you get fx equal to, okay, so I used the pink one before. Okay, so you get x plus e to the x minus log absolute x. So this one is the pink one. Okay, and you're gonna plus by -1, which is my c. Okay, so this is how we answer. We have c equal to -1. The next one, you have f prime x equal to sec x tan x, okay? And you have minus 5 over 1 plus x squared, and you have f0 equal to 3. So you begin number step 1 by you integrate, okay? So you have fx equal to integrate sec x tan x minus 5 over 1 plus x squared dx. And you integrate sec tan, you get secant x, integrate 5 over 1 plus x squared. So it's going to be 5 tan x. Okay, and you're going to add by constant c. Okay. The second one, okay, you're going to find c. So you just use f0 equal to 3 and you plug in secant 0 tan of 0 minus 5 tan 0 plus c. Okay, and everything turned out to be disappear. So this guy equal to 0, this guy equal to 0. So you end up with 3 equal to c in this case. Okay. I not have secant, sorry. So I have only sec 0, right? I wrote secant, it's not correct. Yes. Okay. And sec 0 equal to 1. Okay. So in this case, I have 3 equal to 1 plus c. And so you get c equal to 2. Okay. So you have c equal to 2. And so we get what? We get fx equal to sec x minus 5 tan x plus 2 to be your final answer. So this one you plus c and you get c equal to 2 and you plus 2 at the end. Okay. For the next one, you have if double prime t equal to 3 over root t, if 4 equal to 20 and f prime 4 equal to 7. So for this one, you like to recover the capital F. However, you notice that we not begin with f prime as before. We begin with f double prime. So in order to do this question, you may have to do the thing that we did twice. So in this case, you get, okay, so you have f prime t equal to integrate 3 over root t dt first. Okay, so you let me write this one first. So it's going to be integrate f double prime t dt, and you're going to just integrate of 3 over root 3 dt. So you get 3 and integrate root 3. I told you it's going to be 2 root t. Okay, and this one going to be plus c. Okay, And here we gonna find C. Okay, so you're gonna find C. In this case, you're gonna use F prime 4 equal to you're gonna use F prime 4 equal to 7 in order to find C. It's too big, sorry. So you're gonna find this C. Okay, so we're gonna have 7 equal to F prime 4 equal to 6 root 4 plus C. Okay, and then you get C equal to 7 minus 12 equal to negative 5. Okay, so you'll be able to answer that F prime T equal to 6 root T minus 5. Okay, and this guy is the pink guy. Okay, now we gonna find the second one, which is your fx. So we're gonna do this one again, but we're gonna begin by you have ft, so it's gonna be integrate f prime t dt. Okay, so you integrate 6 root t minus 5. Okay, so it's gonna be what? It's gonna be 6 t to the 3 half over 3 half, because this term is t to the 1 half, right? So this one is t to the 1 half. So you get this one and you're gonna plus c. Okay, and hey, do we have 2c? Is it the same c? So let me distinguish this guy a little bit. So I'm gonna change this one to C1 in order to not confusing you. Okay, so I'm gonna use new notation C1. And for the second one, I'm gonna just use C2. Okay, so to make the calculation clearer. And you see that you have this C2, and then you're gonna find C2 in the second step. Okay, so you're gonna find C2. So you find C2, you're gonna use F4 equal to 20. Okay, so we're gonna find C2 and we're gonna use the green guy, which is F4 equal to 20. So you get 20 equal to F4 equal to 3 here cancel. So you get 2, so you get 4, and 4 to the 3 half plus C2. Okay, so you would get C2 equal to, so it's gonna be 20. Okay, I forgot to integrate 5, right? So sorry, I have to integrate 5 also. I forgot to integrate my 5. So I integrate 5, so it's gonna be 5t plus c2. Okay, so it's gonna be 5t plus c2. So it's gonna be 5 times 4. Sorry, I forgot to integrate my 5. Okay, so this one is 5. You have this one. And you will have C2, kind of difficult. Let me do this one again. So it's gonna be 20 equal to 4 times 4 third, like this one. So it's gonna be 4, and this one will be square root, so it's gonna be 2 cubed minus 20 plus C2. Okay, so you would get C2 equal to 20 plus 20 minus 32. So it's going to be equal to 8. So you get Ft that you can recover equal to 4t to the 3 half minus 5t plus 8 to be your final answer. Okay, so this one will be 4t to the 3 half minus 5t plus 8 to be your final answer. This one will be your third step. Okay, so this one you may have your first, second, third, and you have first, second, third. Okay, so you do this one kind of 2 times. Okay, so okay, so that's it. Final one, the thing that we have been studying can be applied to physics a little bit. So we gonna have the rectilinear motion. Okay, so you have the position function is equal to ft, and the velocity turned out to be just derivative of the position function. So you have vt equal to s prime t, and the acceleration function turned out to be the second derivative of s, so it's going to be derivative of v, so it's going to be v prime t. So this one is acceleration function. So let's do one example. A particle moves in a straight line and has acceleration function given by at equal to 6t plus 4, 6t plus 4. Its initial velocity is equal to v0 equal to negative 6, and the initial displacement s0 is equal to 9. We like to find the position function. Okay, so we like to find the position function. So we know what? We know st, when you dip, you get the velocity. And when you dip this guy again, so you get v prime t. Okay, so you dip s again. So it's going to be s double prime t. So you get v prime t, and this guy will give you acceleration function. And you want to go back 2 steps. Okay, so you want to go back 1 step here, and you want to go back another step here. So we're gonna recover the position function by doing the calculation 2 times like we had before. Okay, so this is what we're gonna do for this example. So we're gonna have first Vt. Okay, so we're gonna have Vt equal to integrate At dt. So you integrate 6t plus 4 dt. So this would give you, okay, this would give you 6 times t squared over 2 plus 4t plus c1. Okay, and so you get what? You get Vt equal to this, so you're gonna know V0 since V0 equal to negative 6, you'll be able to find C1. So it's going to be negative 6 equal to 3 times 0 square, okay, not minus 4 times 0 plus C1. So you would get C1 equal to negative 6. Okay, so this will allow you to have Vt equal to what? Vt equal to 3t squared plus 4t minus 6. Okay, so that's how we have the velocity. This one is your third step. Okay, and for the second one, okay, so for the second one, you have to recover s. So you have st, so it's going to be integrate 3t squared plus 4t minus 6 dt. Okay, so this guy you integrate tt squared, so it's going to be 3 times 3 cubed plus 4 times t squared over 2 minus 6t plus c1. No, not c1, c2. Okay, did I integrate everything right? Yes, it's correct. And then what? And then we're gonna use S0 equal to 9. S0 equal to 9. Okay, so you would get 9 equal to C2, right? So it's going to be 0 square plus 2 times 0 square cube and minus 6 times 0 plus C2. So you would have C2 must be 9, okay? And so you would get ST given by 3t cubed plus 2t squared minus 6t plus 9. Okay, so this is how we get, I forgot over 3. So this one will be no 3. Okay, so this one will be 3t cubed plus 2t squared minus 6t plus 9. Okay, so that's all. Okay, so this is the first lecture on the integration and antiderivative. Okay, it's cover all basic formula, and you want to recover the function if you know derivative of the function. So this is all of the thing that is going to be covered in this first lecture. So we gonna stop here and we gonna continue next time on the what is called definite integral. Okay.